Now we'll talk about the synthetic division. This is a way of dividing x like a linear factor into a polynomial. So synthetic division is a shortcut that can be used when the divisor is a binomial in the form x minus k. So notice x is to the 1 power and has a leading coefficient of 1. In synthetic division, only the coefficients are used in the division process. So write k for the divisor, write the coefficients of the dividend, so the thing being divided, bring the lead coefficient down, multiply the lead coefficient by k, and write the product in the next column. Add the terms of the second column, multiply the result by k. This will make a lot more sense when you see it happen. Write the product in the next column. Repeat steps 5 and 6 for the remaining columns. Use the bottom numbers to write the quotient. And the number in the last column is the remainder and has degree 0. The next number from the right has degree 1, and the next number and so on has degree 2 and so on. So here we go. So 3 goes in the little box here. Then we look at our coefficients. I see. And if something goes missing, like we have x squared, x and a constant, so everything's there. But if we're missing something, we put a 0 for that. So 5 for the x squared, -3 for the x, and -36 for the constant. We put a 0 under the first thing. And the first term, we just add straight down, we get 5. 3 times 5 is 15. -3 plus 15 is 12. 3 times 12 is 36. -36 plus 36 is 0. So the result for this, so there's your remainder. This is the constant. And this is the x coefficient. So it's just going to be 5x plus 12. And so you could, the point to that, given that it's zero remainder, 5x squared minus 3x minus 36 could be written as, I was going to do a parenthesis, you don't need that, could be written as x minus 3 times 5x plus 12. Kind of fun, right? Let's try the next one. So this should be x minus k. So k must be a -2 in this case. So -2 goes in the little box. Then we have 4 as a coefficient, then -10, then -6, then -20. Put a little 0 there. 4 plus 0 is 4. -2 times 4 is 8, so -8, I should say. -10 and -8 is -18. -2 times -18 is positive 36. So -6 and 36 is 30. -2 times 30 is -60. So we get -80. So this would be, unless I made a mistake, or maybe I typed it wrong, I don't know. That's correct, okay. 4, -8, -18, positive 36. Usually you don't see a remainder that high, so this is 4x squared minus 18x plus 30. Notice it was an x cubed. Now it's x squared, it goes down by 1. Plus, and here's a way to write the remainder, -80 over x plus 2. Because I should have been doing it on the other ones for the long division. But you put the remainder over the divisor. And our last synthetic division problem, it's x minus 1, so put the 1 in the little box. We have -9, positive 10, a 7. Now notice I don't see an x here, so put 0 for the x term, and then -6. So the 0 is because we don't see an x over there. It goes from 7x squared to -6. There's no x, so we put a 0 there. So -9 plus 0 is -9. 1 times -9 is -9. 10 plus -9 is 1. 1 times 1 is 1. 7 plus 1 is 7. 8, excuse me. 1 times 8 is 8. 0 plus 8 is 8. 1 times 8 is 8. Negative 6 plus 8 is negative 2. So we started with negative 9 to the fourth, so now it's negative 9x cubed plus 1 times x squared plus 8x plus 8 plus negative 2 divided by x minus 1. It's the remainder over the divisor. Okay, and that does it for this video. The next one we're going to talk about using polynomial division to solve application problems.